Hello everyone, I am Furkan from CS department. Today I'm going to talk about my Physics 1 or 2 project. The topic of my experiment is observing the behavior of equivalent capacitance of binary combined different electric materials. First, I will try to observe the binary combination of the electric materials who are placed side by side into the capacitor.
Gördüm şu an.
Kayıtta değil miydi?
Kayıtta değildim kanka.
Öyle saniye geliyor.
Ver biraz daha. Konuşabiliyor muyum? Ses var mı? 142 diyor. Allah Allah.
Yakaladın da abi 200.
Yok.
Sen kayıtta mı?
Bak kayıttayım şu anda. 105, 106, 107. Biraz daha.
Bu mesafeyi var ya ayarlayamadım.
Geliyor. Geliyor, çok iyi geliyor. 206. Az kaldı. 212.
İşte tam 210. Sıfır 52 falan geldi. Biraz az kaptar. The physical theory of my project as a result of side-by-side placing of two materials with different dielectric coefficients between the conducting plates, the equivalent capacitance is found by considering this system as two separate series capacitors. The capacitance of each separate capacitor are found by the following equations. There are two equations. The materials I used mobile phone as a camera, place, ruler, paper, glass, foam, and experimental setup. The process in this experiment, I measured the capacitance of three different capacitors, which includes combinations of three different dielectric materials. In first part, I measured the capacitance while the materials are individually inside the capacitor. Then, in second part, I compounded the paper and glass together and put them side by side between the conducting plates. Then I calculated the capacitance of capacitor according to equation 1 and 2 by using multimeter. However, the other components of formula, namely as distance and array of plates, are constant. In third part, I compounded the paper and foam together and put them side by side between the conducting plates. Then I measured the capacitance of capacitor according to equation 1 and 2 by using multimeter. However, other components of formula, namely as distance and area of place, will be constant. Fourth part, I compound the glass and foam together and put them side by side between the conducting plates. Then I measure the capacitance of capacitor according to previous equations, and other components of formula will be the same. And I recorded data I obtained while doing this experiment in the form of two separate columns for theoretical and experimental capacitance and three different capacitance values in a table. After that, I calculated the error percentage between experimental capacitance and the theoretical capacitance for each capacitor measurement. Finally, I scratched a graph for dielectric constant of paper glass, paper foam, and glass foam combination and their capacitance values. The graph is capacitance dielectric constant graph. In this graph, the electric constants of paper glass combination, paper foam combination, and glass foam combination are represented in the x-axis, and their capacitance values are shown in y-axis. Now I am going to talk about error analysis of experiment. Under ideal conditions, the experiment takes place in completely vacuumed environment where air and other particles cannot enter the capacitor. Also, the conductive place of the capacitor must not be corroded. However, the experimental value that I found as a result of the air entering the capacitor and the particles it contains, the electrical materials worn out as a result of excessive use, and the ideal non-conductive capacitor place turned out to be different from the theoretical values. In addition, the fact that the cables of multimeter are not ideal and the measurement errors caused by the user can be considered as other reasons for different results. In the first section, where the materials are placed only inside the capacitor, the error rate is 7.62% when the electric is paper, 17.45% when it is glass, and 19.96% when it is foam. In the second part, where the electric materials are placed inside the capacitor in binary combinations, the error margin for paper glass is 9.86%, for paper foam combination 15.21%, for glass foam combination 15.27%. Conclusion of my experiment. In the experiment, the margins of error were not very high, but as a result of both the not ideal conditions and the measurement errors that I have made, I achieved a small margin of error. If I had measured the variables, for example, the distance between the capacitor plates or the electric coefficients of materials more accurately, the values that I have found would have been closer to the theoretical value, and thus I could have obtained lower margins of error. That's the end of my experiment. Thank you for listening.